When you are retrieving data from tables in database, it is often useful to be able to manipulate data values from using functions like formatting, converting, aggregating, and the other things like group by and having keywords in the query, so that it generally groups the results and show aggregation like sum, count, minimum, maximum. So, for example, you want to see the total values of the sales by category, by product, or by customer. So we can aggregate the results using some aggregate functions, as well as using a keyword called group by. So in this video, we will go and explore the built-in functions that we have. We will also look for the scalar functions, the ranking, and the aggregate function as well. We will also be summarizing the data with group by clause and filter the group of the summarized data with the having clause. So if we explore some category of functions, we'll start off with scalar functions. Then there are some logical functions where you'll compare multiple values to determine a single output. Scalar function operates on a single row and returns a single value, while logical functions compare multiple values to determine a single output. There is also a ranking function that operates on set of rows, a row set function that returns a virtual table that can be used in a from clause, and an aggregate function to use one or more input values and return as a single summarized value. So as I mentioned, we start off with scalar function. The scalar function returns a single value and usually work on a single row of data. For example, if we look for a get date function, there is there. So if we explore, like if we select get date and then we'll execute this. Sorry, need to connect to AdventureWorks. This is the sample database that we are connecting. And if we, sorry, for the function we need the parenthesis, and we see get date here, so it is showing today's date and time as well. So this is scalar function. It is returning one row and it is implementing one record as well. We'll use a scalar function and we'll write some query related to that scalar function. One is the function, so if we use select start from SalesLT.Product, and let's execute this, and then we will use air function. So air, and then we'll start off with sell start date, then we'll use product ID and name, and let's see what happens here. Once you execute sell start date, so this is using that built-in function, taking input as a selling start date. And of course, if I include selling start date here, so selling start date here, so we will see a comparison between the air function and the selling start date. So selling start date has a date, you would say, and but this air function is just extracting the air from that selling start date. So what we'll use some more date and time functions there are there. So if I copy this query and let's see what happens. So I'm just formatting this, and I will add more columns here. So one, I've added air. We'll add another function which is called date name, and that date name, it returns a format type of that, or you would say as a sorry, I'll just copy this. So it will return a date name like a month name or something. So this is the format that we have given, and it is showing as the exact date name. So see, this is showing as month. We can do that as dd and see what happens. So this is showing the day. You can also do YYYY, and this will show up the year, So there is another function that we can use. It is called DATEDIFF, and this DATEDIFF, we will first we will sorry in this DATEDIFF we will have that um, it's the difference between two dates or two date elements. So first is we can just figure out what is going on in what is the difference between the number of years. So we'll use the cell start date and then get date function, and then sorry, it's going here, and this will figure out the years old selling order. So this is showing us 22 years. So today is 2024, this is 2002, so it is showing us 22 years of the difference in the date. So to summarize, the date name function returns a different value depends on the date part parameter that is passed on it. For example, that I mentioned returns month name, and the YYY, 4 times Y or 2 times Y, returns the year of that particular date column. And also note that date difference function returns a specific time interval between start date and end date. And in this case, we have used that as years, and end date is determined by get date. So this means that current date. So this is enough of the date functions. Now we will utilize some. So this is basically date functions. Now we'll go through string functions. So first off, I'll start off with this query, copy paste, and then what we'll do is we'll use a concat function, and that concat takes two columns. Like we can take any other option. So I'm just concatenating the first value versus the second value. I mean, combining first name and second and the last name. Okay, so we have changed a query. Instead of using the product, we are using customer to concatenate. So we used first name, last name, customer ID. So just checking this, how it works. So it's just checking because the concat function takes minimum two arguments, as well as you can add up multiple and up to 254 arguments. So this is first column. The second argument is the space. The third argument is the last name. So if I remove this space from this, it will still run, but will not have a gap in between. So that is the reason why we have used three comma separated values with one as a space. So this is showing as first name as last name as a complete full name. Okay, so moving on to the next steps, next functions, next set of functions, what we will use is we will use a product table, and this time we are using the manipulation of substring as well as upper and lower thing. So select I'll use upper function and name as an argument, and I will also add name as a raw table as well. So if we explore this, it is showing as all in uppercase rather than the specific standard case. We can also use name as lower, so that lower means it will come up as lowercase for everything. So for other query, I'll just copy paste here. I'll go to the next step. For other query, I'm adding weight column as well as product number. So if we execute this, it is showing as, let me remove this. It is showing as name of the product, the weight, and the product number. So if you want to round this weight, we will use the round function, and using this, we'll use the round function to round this weight. And please note that this is this is showing as I'm sorry, the round function needs two arguments. There is one thing. The other thing is that this weight needs to be a numeric number, not the string number. So this is showing in the round one, there is a column requirement as well as what precision you want. So we now round to the nearest one to remove the decimal points. So it is showing, although it's using the same one, but is rounding the number like this. So for conversion of the numeric number from the decimal, we can use the cast or convert function as well. Okay, if you look at the product number, it is divided into three sections almost. So one is this, the second one, the middle one, and the first one. So we can use a, a left function to identify anything that is left. So we can use left here, and then sorry, so it is showing as, for example, in varchar number of chars integers. So left function require we start off with the product number, and then we'll specify that how many characters you want to fetch. So if we specify it as 2 characters and then execute, so it will fetch up the 2 characters from the left side. So if showing here is it is fetching 2 characters from the left side. So also we can specify the right function, and we can use the product number and then 2 characters to from that right function. So it is picking up all the values from the right function, but you can see here it's not necessary that it is taking, it's just in a same format. So what do we need to do here is we will be using a function called substring, and let's remove this one and then use substring. I'll use the other line, so for the clarity. So substring, so substring take if you see here, substring take the starting position of integer and length, give it a string. The first is the expression, the other one is the starting point. So if I put up product number here and then starting point here, and then we can, oh sorry, it takes 3 arguments, so the uh, use the to length here. So this will be exactly same as this column, and you see the results are the same for the substring. However, what we need to do is we need to fetch up all the characters and split the string in whenever there is a hyphen there in the product number. So what we can do is we can use another function for that position, start position, to see char index. And there's a function called char index, and that takes, sorry, I'll just use this. And if you see here, it takes an expression to be searched and then starting location. So if you want to consider a starting point, and if you want to fetch the middle number, middle values, then we can use a char index function. And in that char index function, we can specify the value. For example, here, if I, let's use this. This is, what is a character index, you would say. And if we are doing this, it is starting off from, so what we have done here is I've used the product number, I've used the character index function, and I use the starting point as hyphen in the product number, and then move the cursor to 4 spaces. Instead, I can use 5 spaces, and I can see what is the answer that it is returned. So it is returning a middle value, but what it has is it is returning a middle value, but it has a hyphen sign in between. I mean, it's coming through. So we can change this by saying that this character index return the index of that hyphen sign, which is 3. I can add +1 to this and then use 4 characters to bypass, and this will return an exact middle value. So it is taking up the character index as 3, adding this one, so it will move the cursor to the fourth one, and then taking 1, 2, 3, 4 characters from that string and fetching it in the results. So to summarize this, we have converted the product name to the uppercase and lowercase. The product number, which is it has weight, we have converted it, we've rounded this weight to um, the nearest value, and we've reduced the decimal points. We've also used the left and right function to align the product number and fetch the values of that product number. And we've also used a substring function which extract the four characters immediately following the first hyphen character, which is found in the char index function. The size code and everything is mentioned here as well. We can use that as a second hyphen, and then we can explore the option to fetch up the numbers as well. Okay, so what I've done here is, let me scroll here. So what I've done here is I've added another column, and I've used the same one. Sorry. So what I've done here is I've used the same one. I've added another column. I've used the same product number. There's a function called length. I've got the length of the function minus the character index, and I've also used the reverse function that returns the characters of the product number, which is 3. So this means that it is using multiple functions. First is the substring function to extract the two characters following the last hyphen in the product code. That reverse function is reversing the script, the reversing the string, and then passing on to the first three characters. So from the right, from the right side, and then it is taking the total length of those the characters, and then finding the character index based on that. So the first three characters from the right um, is taken through. So this is all with the string function. So after going through all the scalar functions, next what we'll do is we'll go through some logical functions. So logical function is another category of function that allows to determine which of several values is to be returned. The logical function evaluates an input expression and then return an appropriate value based on the result. So this means that, for example, the first function that we will be working on is the is numeric function. So as part of the logical function, what we will do is we'll just write a query, SalesLT.Product, and where size equals 1. Let's execute this. It will give you an error as for previous videos as well, that conversion failed while converting n varchar value n to m. So in that video we used a function called isNumeric. So this is giving me all the details where the size is 1. So this is size, and this is showing me as is numeric size is 1. So in this query we will use name and size, and then we will see the size of that product is equal to 1. This is not working. I don't know why. So this is the query that we are taking through. We are checking name and size, and where the size equals to 1. Here the value is not literally 1, and it's not checking that whether this size has the value 1. It is just it means that it is returning true. So it's checking, this is numeric function is checking whether going through each row and checking the size, the record in the size column, and checking whether it is showing up as a text or a number. So if I do a size 0, this means the non-numeric numbers are displayed here. So we are just checking here using the isNumeric function to get the size as 1, which means a number. We can do a where clause and see where the number, but we need to display whether that existing column is a numeric or non-numeric. So what we can do is we can do add another column, and this time we can use an if operator. This is called if and only if, and is numeric, and I might just copy paste this, equals 1, then you will do numeric num, and then else non num. So now we are checking the name of the product, the size, and whether it is a numeric value or not. So this is showing as a column name, and this is saying as number, and this is non-number. So null is also considered as non-numeric. Now we'll move to another query and just write select from product, the same one. So this is product details, and there is also a function called choose, from which the function returns the value of an ordinal position in the list based on a specific index value. The list index is the list index is based on 1 to 1 based, and then okay, let's add something here. Name, let's add column here, name, and um, and then check which is the product name. We'll also add, and now we'll join a category table, SalesLT.Product category, PRD, PRC, and this is PRD. So we're checking PRD.name and PRC.name. So this is coming from PRD, PRC, and we're just joining this PRD dot product ID, product category ID equals PRC dot product category ID. So this is displaying the both of the names, and this is displaying a category as well. Now what we'll do is we'll add another column that says so now we'll add another column that will say that will have a function called choose, and if I use this, it says the expression and returns an SQL variant, choose index integer comma expression. So basically we are just checking category dot, sorry, not category, PRC dot parent category ID, and we are just checking with the with one expression called bikes, and this is as product type. Let's execute this and see what happens here, and then I will explain. So this is parent category ID, and we are checking parent category ID in that product category table and giving the values, index value, if 1 is giving bikes, and if found as 1 it is giving as values, but if the C handlebars, it is not showing anything. This means there are no bike category available, or there are no component categories available. So I'm just writing it as component as product type. So if I'm executing this, soon you see this will populate as well. So see, component is here. So this is a product type, and this is matching up with the category. So This returns the choose function returns the value of the ordinal position in the list based on specific index value. The list is index is one paste. So in this query, the function returns bike for category one, component for category two, and so on. Let's add prc dot parent, sorry, prd dot parent category id. Parent product category id. So we are checking product category table, and we are checking the parent product category id, and the see how we are running here. So the first index that is found is component. The third index is not written anything here. So now I will just write ABC and see what happens here. So this is showing as category ID. So if it is choosing from a literal first index, second index, and third index, where this product category ID is one, it is showing bikes. It's two, it's showing component, and so on. So we are basically customizing by product category ID. So in this way, we are using choose function to go through all the parents category ID, and in terms of that, we are identifying all the details about the integer based, and we've ordered some. We are ordering the values according to a particular column. Another example we can take here is that let's check select from sales lt.sales order header, and we are changing the sales order ID status. So this is showing as order ID and status. So see, this status is um, this status is numeric. So now we are adding choose, so comma, and then choose, and then we are saying that what is the column? Sorry, status. And then we are saying one is ordered, two is shipped, and three is delivered. Check this out. So since it is 5, we don't have any detail, but if we scroll down, we have to do it some blanks, that is 2 3 4, and then 5 is current, and let's do it old. So I've skipped the index of 4, and then whenever there is 5, it is showing as old. You can do an archive as well. Next, what we'll do is we'll use the ranking and row set functions. Ranking and row set functions are not a scalar function, because they do not return a single value. As per the scalar function, they return a single value, and these function accepts a set of rows as input and return a set of rows as output. So, for example, we'll start off with the ranking function. So let's start off with ranking function, and then I'll start off with select all from production. Sorry, um, SalesLT.Product. So basically, a ranking function allows you to perform calculation against a user-defined set of rows. These functions include ranking, offset, aggregate, and distribution functions. So now what we'll do is in this query, what we will do is we will use the rank function to calculate the ranking based on list price. So we'll use product ID, comma name, comma list price. Let's execute this. So it's showing all the products with names and list price. Now what we'll do is we'll add a rank function, and this is a function which is just defined as an argument. I mean, without any argument inside. And then along with rank, there's a keyword that is used over order by list price, DSC. So descending order, and we'll give an alias of ranking. So let's see what it does. So see, this is the top list price, and this is giving a ranking of 1. And we have, what we can do is, so let's see how it goes. So this is giving a top products with the ranking, and this is giving all the details about how you rank over the order by list price. So it is ranking over the list price, and it is creating something that is that uses the rank function to calculate ranking. And in this rank function, we've defined the over clause to define partitions or groupings within the data. So for example, uh, the price based on rank, that is based on the list price. Okay, so next what we'll do is we'll use the aggregate function, which is very important in SQL query. An aggregate function returns an aggregated values such as sum, count, average, minimum, or maximum. So this means that we can use our data set to summarize the results. So use aggregate functions. So simple one is select first star from sales.product, and we'll use a count function. It will return one value saying that how many products are there in the product. So 295 is the return. So yes, so what we'll do is we'll just execute this, and it will return the distinct one and the category one. So there are 737 categories, 295 products. So further to that, I've added an average function that is also an aggregate function of the list price. So if I execute this aggregate function, we will be able to see all the columns that are aggregated. Next on, we will move to the group by clause. So aggregate function are especially useful when you combine with group by clause to calculate aggregations of different groups of data. So for example, we will run a query from customers table, SalesLT.Customer, and let's count all the customers by salesperson, and comma count customer ID. Yes, customer ID, and let's execute this. So this will give an error that says that it is invalid select because it is not contained in an aggregate function. So whenever you use aggregate function, you have to use the group by clause. And group by clause will include only those columns which are not an aggregate function. So if I execute this now, it will display all the values related to the salesperson as well as the count of customer ID. We can include multiple records associated with that, but every record, multiple columns associated with this table, but for every column we need to include it in the group by clause unless we are using an aggregate function. Next we will move on to the having clause. So After grouping data, you want to filter the results to include only groups that meet specific criteria. For example, you may want to return only salespeople with more than 100 customers. So if I will copy this query, and if I will do where count of customer ID, copy this, count of customer ID equal greater than 100, and let's execute this, sorry. And let's execute this, and it will return an error that says where clause is used unless it's a subquery containing having clause or select list. So this means that the where clause is applied before the aggregation, and the group by clause, the where clause is applied before the aggregation and before the group by clause, so that you cannot filter the aggregation results. So in this case, what we will do is we'll use a keyword called having, and that will be used after the group by. So this means after having the result, having group by implemented, then we will apply the aggregations or filter in the aggregation. So this query will return having clause that is counted with the customer ID, or the customers having the salesperson having greater than 100 customers. So to summarize, it's just group by and having clause together, along with the other functions that are aggregating function. You can also use min, max, average functions as well to fetch up the values of the aggregation. If you're watching me for the first time, please don't hesitate to subscribe and like. Also, I would appreciate if you'll provide your feedback so that I can improve. Thank you so much.